Sound!
All right, sound. We're talking about sound. We're talking about a wave of compressed frequencies. It's going to be within the range of whatever the organism that's hearing it. So when we're talking sound, you have to be able to register it in your ears
Right.
or spiracles if you're some kind of insect or something like that.
And remember, frequency is just simply the measurement of the number of waves that pass a certain point in a second.
In a
And
second.
It's measured
That's
in
hertz.
And the more waves that go past, the higher the frequency.
So sound waves are actually longitudinal waves.
Yep.
One thing we didn't mention is the reason you detect sound is because it's actually particles in the air being compressed and also rarefacted, and you are able to sense that. Now, since they're compressions and rarefactions, it is a longitudinal wave. Remember, longitudinals are the ones that are compressed like this, transverse the ones that actually go up and down.
And if you ever looked at a speaker, where you see the speaker
Yep,
moving out, especially
vibrating.
like the real low frequencies like a subwoofer, it's the same kind of thing that your eardrum kind of does. It's just vibrations that compress and rarefact the air.
Yeah, because
Yep.
there's these little
And that's how
bones in
you
your
register
ear,
it.
little bones in your
Yep.
ear, and what happens is the compressed sound particles come, and it hits the
Vibrate.
bones and vibrates the bones, and then your brain interprets that as a sound.
Yep.
Pretty amazing.
Awesome.
So, and this is what Mr. Black just said.
Yeah.
Sound is actually produced when objects vibrate, and it makes compressions of the air molecules. We have kazoos up there. The way a kazoo works is you blow into it, you actually make this little wax paper vibrate at a really fast frequency, and it creates compressions
Right.
in the air, and then you hear that sound.
And the way you talk is when you are speaking, you're actually moving air across your vocal cords, and they're vibrating at
vibrate.
different
Yes,
frequencies.
that's why if you talk, feel your throat right here, you
Yep.
feel the vibrations. Those vibrations are what are making compressions in the air.
Yep.
So that you may
All
It's
true.
make sound.
disturbances in
All
medium.
true. So, because sound travels as a longitudinal wave, it's also known as a mechanical wave because it needs to have a medium to travel through. So, you may have seen this great movie that I think I can say without violating any copyright issues called, anybody?
Alien.
Alien, right, where the tagline on it
Space.
is that in space,
No one can hear you scream.
Right.
Which is scientifically accurate.
that's true. You would basically sound like this.
It hurts so bad.
And the reason why it can't travel through space is because there's not enough air particles or particles close enough to each other to actually transmit the energy from one to the next. So you get no sound out of it.
Yeah. So if there was an explosion in space in another movie, you wouldn't actually hear it.
Not
right?
unless you were on the ship,
Yeah.
inside
you would
of it.
hear it because
Yeah, but
the
if you
air
were-
inside the ship, but if you're outside there in space,
You're not going to hear
it's
it. It would just be
silent.
like,
Okay.
that would
Yep.
be pretty much
So
it.
that one's kind of violated by a lot of movies.
Yeah, but it's a lot
Yeah.
more fun to
It's
hear
way more exciting.
as opposed
Ex-
to...
explosions are exciting when they're quiet.
No, they're
Although
not.
there have been some movies that do that, though. So, yeah.
Anyway,
Anyways.
so the loudness of a sound is how loud you interpret it as is based on its amplitude. Now, I will say the chart on the bottom, as we said, sound is a
It's longitudinal.
longitudinal. I'm sorry, I was about to say compressional. Longitudinal wave. So showing it as transverse waves down there isn't really that accurate. But you will notice if you've ever played with any sound programs, they actually make the sound waves go up and down. That's because it's way easier to show the amplitude of
Exactly.
the
That's what
waves
it is.
that way.
Otherwise, you'd have to be measuring the size of the compression versus the rarefaction, and it's just not as easy to see.
Yeah,
So-
it's tough
Should
to
we
see.
give an example of a low amplitude? A small amplitude sound is like that.
And a loud amplitude sound is like this.
Louder!
And just like this is normal.
Yep.
Yep.
But anyway, and we measure loudness in decibels. And I've actually included a chart here. We're not going to spend too much time on it. But if you want to look at it, it's kind of interesting. Shows how many decibels certain common objects, how
Yeah.
the decibel
And
levels
the
are.
higher the decibels, the issue with decibels is because it's all about vibrations, the higher your decibels, you actually can cause damage to your hearing.
Yeah,
It can
'cause
make
you're
your
permanent
vibrate so
damage
much
to
it
it.
rips.
Right.
That's-
To the
Yeah,
point
it's
where
like
it can't
tearing
be
a muscle.
fixed.
Yeah.
And there's actually a lot of talk about with the use of earbuds so much these days, and
Yeah.
how loud certain students listen to their
It actually
music.
does.
I'm not going to
certainly,
name any
certainly
of you,
no one in our
right?
classes.
But there's actually concern that students may be damaging their ears permanently. So there you go.
And then kind of the final characteristic of sound is pitch.
Pitch, right. So pitch is determined by the frequency, so how fast or how slow the wave is actually traveling. And if you have a really high frequency sound, you get a high pitch. So it's like, ah, versus
wonderful.
low frequencies is like this.
So now low frequency means there's less waves per second.
True.
So when I talk like this, my voice is making less waves per second. Whereas when I talk like... I'm not going to talk that way. But when I talk in a high voice...
Oh, you
totally
totally-
doing more waves,
Yeah.
just like that.
Yeah, when I talk like in a high voice, there's, it's a high pitch. That means
High
it's
pitch,
a high frequency,
more
more waves
waves.
per second.
Yep. And if you
Fewer
notice,
waves.
pitch is measured in hertz
Just
because
like frequency.
It's, right, because it's just a measurement of
Yeah.
frequency.
Pitch and frequency are really like the same thing. It's
Pretty
just
close, yes.
we only really use pitch to apply to sound,
Sound.
Right.
whereas frequency applies to all waves.
Any wave at all.
So if you talk about the frequency of a sound, it's the pitch.
It's the same as pitch.
Yep.
Yeah.
We're good with that.
So, and I believe, oh no, I had kind of an interesting thing. Oh, it gets cut off a little bit, but
Yeah.
you can figure out what animals those are. But many animals hear different ranges of pitches. So there's a certain amount of sound that we can't actually hear. And this actually varies from human to human even.
Yep.
It's just averages. But you'll notice there are other organisms that have different ranges of sound frequencies they can hear. Like there are certain high noises, if you look at the dog, that humans can't hear. And likewise, there are low noises that humans can make that dogs can't
Right.
hear. because
So
it's
if
too
you
low
ever want to
frequency.
make fun of your dog without them knowing what you're talking about, just talk really, really low.
Yeah. So,
That's
anyway.
cool, though.
It is pretty sweet.
All right.
It's neat, so you can see at 1,000 hertz that
Yep.
the bat can't even hear that.
Yeah.
But it can go well over 100,000, which we
Mhm.
can't.
True.
Awesome.
And finally,
Speed of sound.
Speed
You're
of
gonna talk for a
sound. The
while.
speed of sound. Yeah, I was just back here. Enjoying your sound.
We forgot about
Speed
you.
of sound. It's easy to do.
You were so quiet. Your pitch was so
300.
perfect, and your loudness was so small.
I know.
Okay, sorry.
Speed of sound, you guys, is about 343 meters every second, which means that speed literally travels 343 meter sticks in a second.
It's fast.
Which is fast. It's very fast, and that's in air now. But in different kinds of medium, it'll travel at different speeds. A solid medium, it actually travels the fastest. So even as fast as that is in air, which is a gas,
Yep.
it's still pretty darn slow compared to how fast it would travel in something solid.
Right.
So
What about temperature? Does that affect it?
temperature affects it big time.
Oh.
So it's going to
Oh.
travel faster in warmer temperatures because molecules in something that are warm are already kind of ready to move and they've got a little freedom, a little more energy in there. And as you add sound energy into that, they vibrate all the faster and carry that wave faster. So a warm solid, fastest sound travel. A
Sweet.
cold gas, like a cold day outside there, is going to be the slowest sound travel.
Yeah. And sound just doesn't seem to travel as effectively in colder weather. Have you guys noticed that before?
Yeah.
Yeah.
I
and
don't
it
really
is-
have
it's got-
massive evidence to back that up.
No,
I'm
but it's
just-
got to
A
do a
little
little bit
anecdotal,
with
but
yeah,
it's
got
all
to,
about it's about temperature.
yeah,
Yeah.
low kinetic energy, and we'll learn about that in a couple of minutes.
All right, and that is it.
Excellent.
Have a good day.
Peace.